In November 2019, a vehicle rolled onto a stage in Los Angeles that looked less like a car and more like a mistake. Sharp edges, flat steel panels, no curves, no paint. It didn't resemble anything sold on the road before it, or anything that most people wanted to see again. Within minutes, it became one of the most mocked vehicle launches in modern history. And yet, behind the memes, the jokes, and the viral failure, there was something deeper happening. Because the vehicle you're looking at wasn't designed to be liked, it was designed to break rules. This is the story of the Tesla Cybertruck, a machine that many called ugly, impossible, or even pointless, but one that may end up changing how vehicles are built forever. And to understand why it exists at all, we need to go back. Not to Tesla, not to Elon Musk, but to a problem the auto industry never wanted to solve. For decades, pickup trucks have followed the same formula. Big engines, heavy frames, rounded steel bodies, and just enough innovation to look modern without actually changing much. Manufacturers knew one thing for sure. Pickup buyers hate radical change. So trucks evolved slowly. Bigger grills, taller hoods, more chrome. But underneath, the same basic construction remained. A steel frame, panels welded and stamped into complex curves, painted in layers, repaired easily, replaced easily. This wasn't just tradition. It was economics. Factories were optimized for curved metal. Supply chains were built around stamping presses, and any vehicle that didn't follow those rules became incredibly expensive or impossible to mass produce, which is why no one tried to reinvent the pickup truck. No one, except Tesla. By 2018, Tesla was no longer a startup fighting for survival. The Model S had proven electric cars could be fast. The Model X showed people would accept radical design. And the Model 3 was becoming a global bestseller. But Tesla had a weakness. Every Tesla vehicle used aluminum-heavy construction. It was lightweight, efficient, and expensive. Pickup trucks, on the other hand, demanded something different. They demanded strength. They needed to tow. They needed to haul. They needed to survive job sites, farms, and real abuse. Aluminum worked, but it dented. Paint scratched, panels warped. And most importantly, aluminum pickup trucks were very expensive to repair. Tesla couldn't just make another electric truck. If they did, it would be compared directly to Ford, Chevy, and Ram, brands with a century of truck loyalty behind them. So instead of competing inside the rules, Tesla decided to delete the rulebook entirely. Inside Tesla's design studio, engineers were asked a strange question. What if we didn't paint the truck at all? Think about that for a moment. Paint is one of the most expensive steps in vehicle manufacturing. It requires massive facilities, toxic chemicals, quality control, and constant maintenance. Removing paint would reduce cost. It would reduce complexity, and it would remove scratches as a concern. But there's a problem. Unpainted steel rusts. Unless it's not normal steel, Tesla turned to cold-rolled stainless steel, the same type used in rockets, specifically a variant related to SpaceX's Starship alloy. This steel was extremely hard, corrosion-resistant, nearly impossible to dent with normal force. But it had a fatal flaw. You cannot stamp it. Traditional car panels are pressed into curved shapes using enormous machines. This steel cracked under that pressure. It could only be bent in straight lines. At this moment, Tesla faced a choice. Abandon the material or abandon curves entirely. They chose the second option. The Cybertruck's shape wasn't futuristic because Tesla wanted it to be. It was futuristic because it had no choice. Flat panels, sharp angles, simple geometry. The design wasn't inspired by supercars or science fiction. It was inspired by manufacturing constraints. Ironically, what the internet would later call lazy design was actually the opposite. This was one of the most difficult vehicles ever attempted. Every line on the Cybertruck exists because the material demanded it. Every angle was calculated not for style, but for survival. When Elon Musk first teased the Cybertruck, most people thought it was a joke, a polygon meme, a Minecraft vehicle, a concept car that would never reach production. Even industry experts assumed Tesla would soften it before release, round out the edges, add some curves, make it look, well, normal. They were wrong. On November 21st, 2019, Tesla unveiled the Cybertruck exactly as designed. No curves, no paint, no apologies. The crowd didn't know what to think. Was this real? Was this actually happening? And then everything went wrong. To prove the truck's durability, Tesla demonstrated what they called armor glass. A metal ball was thrown at the driver's window. It shattered. Then the passenger window. It shattered too. The crowd gasped. Elon Musk stood there, visibly shocked. The internet exploded. Within hours, the Cybertruck became a punchline. Memes flooded every social media platform. Late-night shows had material for weeks. But something unexpected happened next. Despite the embarrassment, despite the broken windows, despite every reason to walk away, pre-orders flooded in. Hundreds of thousands. Then over 1 million reservations. People didn't just accept the Cybertruck. They were curious about it. Some loved it. Some hated it. But no one ignored it. And in an industry built on safe decisions, on focus groups and market research, that alone was revolutionary. Most companies would have redesigned the truck immediately, rounded the edges, painted the body, made it normal. Tesla didn't, because the Cybertruck was never meant to blend in. It was meant to challenge a simple idea. What if vehicles weren't styled to please people, but engineered to last longer than fashion itself? Think about it. Traditional cars age poorly. Paint fades after a few years in the sun. Plastic trim cracks in the cold. Chrome peels. Designs date themselves within a decade. A car from 2010 looks old in 2020. A car from 2000 looks ancient today. Tesla wanted something different. A vehicle that looked strange today but wouldn't look outdated tomorrow. Stainless steel doesn't age. It doesn't fade. It doesn't rust. It just exists. The DeLorean tried this in the 1980s and failed commercially. But the car itself? It still looks the same today as it did 40 years ago. Tesla was betting on a similar principle. Build something so different that time can't touch it. But there was a bigger problem. Designing a strange truck was one thing. Building it at scale was another. The Cybertruck wasn't just hard to manufacture, it was almost impossible. Factories had to be redesigned. Tolerances tightened beyond industry norms. Panels aligned without paint to hide mistakes. Every flaw would be visible. Every imperfection would show. And Tesla hadn't even solved the biggest challenge yet: safety. Modern vehicles are designed with crumple zones, curved metal that absorbs impact, materials that deform predictably in crashes. The Cybertruck didn't deform easily, it resisted, which raised a terrifying question. What happens in a crash? What happens to the people inside? What happens to the other vehicle? This question nearly killed the project. Regulators weren't convinced. Engineers were nervous. The internet was ruthless. But Tesla pushed forward, not because it was easy, but because they believed the future wouldn't look like the past. And this was only the beginning, because the Cybertruck wasn't just a truck, it was a test of whether the auto industry could survive radical change, a test of whether consumers could accept something truly different, and a test of how far engineering could go before reality pushed back. When Tesla revealed the Cybertruck to the world, most people thought the hard part was over. The design was done. The idea was out. The internet had already made its jokes. But in reality, the Cybertruck's biggest challenge had only just begun. Because designing a vehicle that looks impossible is far easier than building one at scale. And what Tesla was attempting had never been done before in the automotive industry. Traditional car factories rely on forgiveness. Paint hides imperfections. Curves disguise panel misalignment. Flexible materials absorb small errors. The Cybertruck had none of that. No paint, no curves, no visual forgiveness. Every panel was flat stainless steel, which meant any misalignment was obvious. Any warp was permanent. Any mistake was visible from meters away. Tesla engineers quickly realized something terrifying. Their existing factories were useless for this vehicle. The Cybertruck didn't just require a new production line. It required a new philosophy of manufacturing. The same steel that made the Cybertruck strong made it brutally difficult to work with. This stainless steel destroyed traditional stamping machines. It wore down cutting tools rapidly. It refused to behave predictably under stress. Bending it even a few millimeters too far meant scrapping the entire panel. And because the panels were huge, mistakes were expensive. Very expensive. Tesla had built fast factories before. The Model 3 production ramp was legendary and painful. But this wasn't about speed. This was precision under pressure. Originally, Tesla promised production by 2021. That date came and went. Then 2022. Then 2023. Each delay fueled skepticism. Critics claimed the Cybertruck was vaporware, a fantasy that would never materialize. Investors questioned whether Tesla had gone too far, and competitors quietly hoped it would fail. But behind the scenes, Tesla wasn't idle. They were fighting physics. Pickup trucks traditionally sit on a body-on-frame design. It's strong, it's proven, it's heavy. The frame is separate from the body, connected by bolts. This design has worked for 100 years. Tesla wanted something different. The Cybertruck would use a structural exoskeleton-like approach, where the body itself carried loads. The skin wasn't just covering, it was structure. This decision was revolutionary and dangerous because if the structure failed, everything failed. crash safety, towing capacity, longevity. There was no fallback, no plan B. Regulators didn't care how strong the Cybertruck was. They cared about what happened to people inside it. Stainless steel doesn't crumple easily. Flat panels don't dissipate energy like curves do. Tesla had to prove that the vehicle could absorb impact safely, that it wouldn't become a rigid battering ram in collisions, that pedestrians wouldn't be at increased risk. This forced Tesla to redesign internal structures repeatedly, hidden crumple zones, energy-absorbing subframes, complex internal geometry concealed beneath simple surfaces. From the outside, the Cybertruck looked simple, almost primitive. Inside, it was anything but. To solve alignment and structural problems, Tesla doubled down on something radical. Gigantic casting machines called gigapresses, capable of producing massive vehicle sections as single pieces. Instead of welding dozens of parts together, Tesla aimed to cast huge structural components, reduce tolerances, increase rigidity, lower part count dramatically. This worked beautifully for other Teslas. The Model Y used it to great effect. But the Cybertruck pushed the limits. Casting thick structural components for a vehicle this large had never been done before. Failures were common. Castings cracked during cooling. Cooling times were unpredictable. Quality control was a nightmare. But slowly, painfully, progress happened. At multiple points, walking away would have been logical. The Cybertruck was over budget, behind schedule, mocked relentlessly. Any traditional automaker would have killed the project, cut their losses, moved on. Tesla didn't, because the Cybertruck wasn't just about selling trucks. It was about proving a principle, that vehicles didn't need to be disposable, that manufacturing didn't need to follow old rules, that the future could look uncomfortable at first. When early production units finally emerged from the factory, they weren't perfect. Panel gaps varied. Edges were sharp, sharper than expected. Fit and finish sparked immediate controversy. Critics jumped on every flaw. This is unacceptable. This is unfinished. This would never pass quality control at Ford or Toyota. They weren't wrong, but they also missed the point. The Cybertruck wasn't built to feel familiar. It wasn't built to match the refinement of luxury trucks. It was built to resist dents, avoid paint degradation, handle abuse, age differently than any modern vehicle. Tesla wasn't chasing perfection. They were chasing durability, and that trade-off would divide opinion instantly. Once the Cybertruck hit real roads, the internet reacted again. Videos tested everything. Bullet resistance, sledgehammer hits, off-road capability, towing performance. Some tests impressed. The steel body really did resist impacts that would destroy normal trucks. Others embarrassed. Range dropped significantly under heavy load. The truck struggled in some scenarios where traditional trucks excelled. The Cybertruck didn't dominate every category, but it refused to disappear. Was the Cybertruck a failure, or was it simply too early for people to understand? Because despite the criticism, despite the mockery, orders remained strong, and competitors started paying attention. Flat panels, structural batteries, simplified manufacturing, gigacasting. Suddenly, ideas that once sounded ridiculous didn't anymore. Tesla had done something that many thought impossible. They forced the industry to reconsider its assumptions. Because surviving the internet is one thing. Surviving real owners, real weather, real accidents, that's another. And this is where the Cybertruck's most serious controversies would begin. By the time the Cybertruck reached customers, the debate was no longer theoretical. This was no longer about renders, promises, or stage reveals. This was about reality. Real roads, real owners, real consequences. And reality is always less forgiving than the internet. Early Cybertruck owners didn't behave like normal buyers. They tested limits. They filmed everything. They pushed the truck into environments it was never designed to hide from. Off-road trails, construction sites, harsh weather, snow, rain, desert heat, everyday city traffic. And slowly, a clearer picture began to form. The Cybertruck was not fragile, but it wasn't invincible either. The stainless steel body resisted dents impressively. Shopping carts bounced off. Minor impacts left no marks. Scratches behaved differently than on painted cars. They didn't rust. They didn't spread. They just existed. But durability came with trade-offs. Fingerprints showed easily on the brushed steel. Surface blemishes couldn't be hidden with wax or polish. Repairs were more complex than traditional panels. You couldn't just sand and repaint. Owners learned quickly that this wasn't a truck you could casually fix at any body shop. You needed specialized equipment, specialized knowledge. The Cybertruck didn't just change how a vehicle looked, it changed how ownership worked. Tesla's strength has always been software, and in many ways the Cybertruck benefited from that. Over-the-air updates improved driving behavior, steering feel, suspension tuning, interface responsiveness. Features that didn't exist at launch appeared months later. The truck literally got better over time. But software couldn't fix everything. Physical limitations remained physical. The truck's size, its weight, its visibility challenges, and no update could rewrite first impressions. This is where the Cybertruck created a rare split. Owners often describe the truck as surprisingly usable, comfortable for its size, stable under load, genuinely practical for daily use. The public, however, focused on sharp edges, parking challenges, design controversy, safety concerns. Two realities existed at the same time, and Tesla struggled to control the narrative. Crash tests, real-world incidents, and edge case scenarios reignited criticism. Some questioned pedestrian safety, the flat, hard surfaces, the sharp angles. What happens if someone is hit? Others questioned repair costs after accidents. Insurance companies watched closely. Some raised rates. Some hesitated to cover the vehicle at all. The Cybertruck wasn't unsafe. It passed federal safety tests.
Cybertruck's low center of gravity, exoskeleton, and advanced crash structure are what earn it that 5-star overall crash safety rating.
But it forced regulators, insurers, and manufacturers to ask uncomfortable questions. Questions about what modern safety should look like. How much design freedom is acceptable? Whether durability should outweigh compatibility with existing infrastructure. Tesla didn't just sell a truck. They introduced a problem the industry hadn't solved yet. Publicly, competitors mocked the Cybertruck. Press releases were carefully worded. Executives made jokes at auto shows. Privately, they studied it. Flat panels reduced complexity. Large castings reduced part count. Structural integration simplified assembly. Even if they never copied the design, they absorbed the lessons. Ford's F-150 Lightning used more aluminum. Rivian used advanced manufacturing. GMC experimented with simpler body designs. The Cybertruck's influence spread quietly through the industry, and that might be its biggest impact, not imitation, influence. Was the Cybertruck profitable? Tesla hasn't said clearly, and that silence speaks volumes. Early production costs were high, delays consumed capital. Scaling remained difficult, but Tesla had never relied on first-generation profitability. The Model S lost money initially, so did the Model X. They relied on iteration, and iteration requires survival. The Cybertruck arrived at a sensitive time for Tesla. Increased competition from traditional automakers, tightening margins, rising expectations from Wall Street. This wasn't the era where Tesla could afford unlimited experimentation. And yet, they experimented anyway, because the alternative was stagnation. The alternative was becoming just another car company. So was the Cybertruck a mistake? That depends on what you measure. If success means universal approval, then yes, it failed. If success means redefining how vehicles are imagined, then no. The Cybertruck didn't try to please everyone. It tried to challenge assumptions, and that has consequences. Years from now, the Cybertruck may be remembered in one of two ways: as a bold miscalculation, a moment when Tesla's ambition exceeded its grasp, or as the moment the industry realized that playing it safe had limits. Either way, it won't be forgotten. And in the automotive world, being unforgettable matters more than being perfect. The Cybertruck was never meant to blend in. It was never meant to be comfortable for the industry, and it was never meant to be easy. Tesla didn't build the Cybertruck to win arguments. They built it to force change. Whether that change was worth the cost is something only time will answer. But one thing is certain: the conversation about what vehicles can be, what they should be, and how they should be built, that conversation changed forever. And sometimes that's enough. The Cybertruck was never just a vehicle, it was a question. A question about how far design can be pushed before it breaks tradition, about whether innovation should prioritize comfort or confrontation, and about how much risk a company can take when it's already changed an industry once before. For Tesla, the Cybertruck wasn't about selling the most trucks. It was about refusing to repeat the past. Every sharp edge, every manufacturing delay, every controversy wasn't accidental. They were symptoms of a company still willing to gamble, even when the odds were unclear. Some will see the Cybertruck as a warning sign, others will see it as a necessary disruption. But history rarely rewards the safe option. Many of the ideas that now define modern vehicles were once mocked, doubted, or dismissed. And many bold experiments failed before one finally reshaped everything that followed. The Cybertruck exists in that uncertain space, between failure and influence, between mistake and milestone. Whether it becomes a turning point or a footnote will depend not on headlines, but on time. Because the most important stories in the automotive world aren't written in press releases or reveal events. They're written years later, when we can finally see what truly changed. If you want more stories like this, the risks, the failures, and the ideas that challenge the industry, this channel explores them one vehicle at a time.